ICs and boundary conditions that its abbreviation is BCs in order to define a problem, the solution that is well posed is required. And this equation, this condition should be proper. If they are not proper, the problem return to ill-posed problem. And the well-posed problem is very well, but ill-posed problem cause the problems, cause the trouble for my solution. If a problem has too many conditions, there will be no solution. And if too few conditions for a problem is available, these conditions cause the problem to be, the solution will not be unique. The solution of the problem of the PDE is not unique, and the unique solution is more efficient and it is required for accuracy. If the ICs and BCs are specified in the wrong place or at the wrong time, then the solution will not depend smoothly on the IC and BC, and a small error in IC and BC will bring about large change in the solution. The goal of this part, please be careful and pay attention to me. This part, it wants to say that ICs and BCs are important. And when we have PDEs, the ICs and BCs should be determined proper. If they are not proper, they are causes the ill-posed problem. For example, if we have too many conditions, the solutions, the problems will be no solutions. If we have few conditions, the solutions will not be unique. And the proper initial conditions cause to well-posed problem. For the second order elliptic equation, we require a boundary condition on U at each point on the boundary. Please pay attention, this part is important. This part is important and determine the initial and boundary condition for elliptic, parabolic, and hyperbolic equation. A second order elliptic PDE require boundary condition, means elliptic equation is boundary value problem because they need boundary condition. The elliptic PDE are called boundary value problem, BV. BV is abbreviation for boundary value problems. So elliptic PDE require a boundary condition on U at each point on the boundary, and thus they are called boundary value problems. The parabolic equation, linear parabolic equation require initial condition at the initial start time, and means that t equals 0, and one boundary condition at each endpoint of the special domain. Thus, we learned that a parabolic equation require initial condition and boundary condition, but elliptic PDE only require boundary condition, but parabolic equations require initial condition and boundary condition. And a linear hyperbolic equation require initial condition and many boundary conditions. and the boundary condition that require for hyperbolic equation depended on the sign of C. If C in wave equation is greater than 0, we need initial condition U 0 and is equal to F, and boundary condition U, T and 0 equal to G. If C is smaller than 0, we need initial condition only, and we don't need boundary condition. Thus, for hyperbolic equation, the boundary condition dependent of the sign of C. C is the wave speed. If the C is greater than 0, we need initial condition and boundary condition. But if C is smaller than 0, we need only initial condition and we don't need boundary condition. If C greater than 0, the hyperbolic equation is called initial condition. But when initial and boundary condition, but when C is smaller than 0, the hyperbolic equation is called only initial condition or initial value problem. Okay? I will repeat this part. We have three types of PDE: elliptic, parabolic, and hyperbolic. In elliptic equation, in elliptic PDE, we require only boundary condition, and the elliptic PDE is called boundary value problem, BVP. When we said the BVP means boundary value problems. In the linear parabolic equation, we need initial condition and boundary condition, and this type of equation are called IVP, means initial boundary value problems. For hyperbolic equations, the boundary conditions depend on the sign of C. In hyperbolic equation, always we need initial condition. Initial condition is needed always. Always we need initial condition. But boundary condition dependent on the sign of wave speed C. If C greater than 0, we need boundary condition, and this situation, the problem is called initial boundary value problems, or IBVP, initial boundary value problems. But in the first case and in the second case that we have not boundary condition, the problem is called initial value problems, or IVP, initial value problems. Okay? Are you understand? Yes or no? Are you present?
Yes.
Are you present? Okay. I have sent this file to WhatsApp group. Okay, yes?
Yes.
Are you received it?
Yes.
حتما همین امروز و فردا مطالعه داشته باشید. اگر سوالی دارید میتونید بپرسید، من بهتون جواب میدم. Please study this part of lesson, this part of file, and if you have any question, I respond to you in WhatsApp. And for the next session, please understand the part 1.5, this part. Please study. And 1.6, verification and validation of the result. Do exercise in page 16. And the next session, we start the finite difference method. And at this term, we study the finite difference method for elliptic and parabolic and hyperbolic equation. After you learn this finite difference method for this problem, for this PDE, you start the programming with MATLAB for this type of equation. It is study the course, study the lessons, study the lecture, and be present in all of the classes. Okay?
Okay.
Okay.
If you have any question, you can let me ask you if you have any question.
No.
Let me know if you have any question, any problem, any comment.
لا ممنوع.
Okay. This session is finished.